Welcome to Share Science. Have you ever heard the term "it's like moving mountains" and wondered where it came from? Mountains seem so permanent, but did you know they actually move every day? Today, we're going to learn what it takes to move a mountain and how scientists actually study how the Earth moves mountains every day. We're going to cover 3 key things to better understand how mountains are made. We are going to explore the tectonic plates that make up the surface of the Earth. Then we are going to explain slab pull as a critical geological mechanism that literally moves mountains. Finally, we are going to discover how scientists use core drilling to look back in time to better understand how mountains formed millions of years in the past. The world as we know it looks like land jutting out of the ocean, but underneath the surface is a sea of molten rock that's under enormous pressure and is always moving. The molten rock rises as it's heated by the Earth's core and spreads sideways as it approaches the surface. As it loses heat near the surface, it sinks back down, which slowly drags the Earth's crust along with it, ultimately causing the continents to move. Where the plates collide, the seabed is dragged back down, pulling layers of dead plankton and other carbon-rich material deep into the Earth. As it sinks, this material is heated, melting the rock and releasing carbon dioxide, which makes its way up to the surface that we recognize as volcanoes, which return the carbon back to the surface when they erupt. Let's watch what these amazing eruptions can look like. So what's slab pull got to do with making mountains? As the adjacent tectonic plates push up against one another, different materials in the geologic stack of rock begin to deform and stack up, folding more and more upwards as the slab continues pushing forward. Scientists can use sand models to mimic how these different layers move to resemble the kinds of mountains we see all over the planet. By looking at rock types that can be found on the face of a mountain, scientists can determine how old a mountain is and how fast it's moving. That's why you can sometimes find sea life fossils on the peak of a mountain. The other way scientists can understand the history of a mountain is by drilling cores out of the ground to look at the types of rock that are present at different depths. By drilling into the rock with a hollow bit using a very tough cutting bit, a core sample can be pulled up to show how the rock changes, allowing the scientist to differentiate rock that was formed on the bottom of the seabed, for instance, from rock that was formed under intense heat and pressure under the Earth. This helps researchers know about how stable a mountain is and how quickly it may be moving, up to several millimeters every year. That may not seem like much, but it can add up, creating mountains like Everest that stands at 29,000 feet. To summarize, we learned that the Earth's surface is made up of numerous tectonic plates that are constantly moving and shifting against one another, being pushed from below by molten rock that's heated from the Earth's core. As this rock cools, it pulls surface rock along with it, creating ripples on the surface that eventually turn into mountains. By studying mountain surfaces, as well as drilling core samples from deep underground, scientists can better understand how mountains form and how the Earth will continue to move in the future. We hope you liked today's video. Let us know what you think in the comments. Please like and subscribe to get more content just like this, and you can really help us out.